Okay, so this video is going to be for 4.3a Hawks homework. And this particular section is other common functions. And like we mentioned in the notes, we have these four what we call parent functions that we need to be able to memorize so that we can manipulate them easily. And so the first problem that we're going to take a look at, we are going to get a function f of x, and that is going to be equal to 9 over 7 times the absolute value of x. And so what's going to happen is, in Hawks, they're going to ask you a couple of things. And so we have to be able to look at this, and we have to know which parent function we're dealing with. And in this particular problem, we are dealing with the parent function, the absolute value. So I'm going to jot a few notes down just for the first problem so we know what's going on. So my parent function is absolute value. And in our mind, we need to know very quickly that the absolute value has a vertex of 0, 0, and then it's going to look something like this. So that's what should come to our mind as soon as we see this. Now, we're going to come back to our original problem, and since we know that this is a nice, neat number that is positive, that tells me that whatever my graph actually does look like, it's definitely going to open up. Okay, so that's even further proof that my graph is going to look something like this. Now, what's going to happen is, in Hawks, they are going to ask you to find 2 points that are on this graph other than the origin, which in this case happens to be the vertex. Okay, because we know that the vertex of the parent function, absolute value of x, is 0, 0. And so we have to find 2 other points that are not the origin. And so what we're going to do is we're going to make real quick an XY chart just like we did in our notes. And if we know that our parent function is the absolute value of x, we want to know what's happening close to the origin. So we're going to pick some numbers that are close to the vertex, which happens to be 0, 0. So why don't we pick -1? We already know that the vertex is 0, 0. And then let's pick +1. And so what's going to have to happen is we're going to find f of +1. And so that's going to be 9/7 times the absolute value of 1, which is just going to be 9/7 times 1, which is just 9/7. And so we're going to have the point -1, 9/7. And so we're going to do this again. We don't have to worry about finding 0, 0 because we know that this is the vertex. Okay, that's been given to us at the beginning. We know that in our mind, so we don't have to plug that in. So let's find f of +1. Okay, that's going to be 9/7 times the absolute value of +1, which is just 9/7 times 1, which is again 9/7. So I have the point 1, 9/7. Now, in Hawks, what they're going to ask you to do is type in this point, -1, 9/7, and also type in the point 1, +9/7. And then what's going to happen is the graph itself will be pre-populated. You're not actually going to have to graph it. Okay, but I want to make sure that if you had to do this on the test, you could. And so really quickly, we're going to draw a quick graph. And we're going to say, okay, well, we're going to graph -1, 9/7. And we're not exactly sure what 9/7 is, but we know it's definitely greater than 1. And so we're going to go over -1. We're going to go up 1 and, a little bit more. It doesn't have to be perfect. We just need somewhat of an idea. And so our vertex, of course, is 0, 0. And then the second point that we found was +1, 9/7. And so that's close to about 1 1/4. And so we're going to scooch over to the right, and we're going to go up 1 and about 1/4, just like we did on the left-hand side. And since we know this is an absolute value problem, we know that this has to be a nice, neat, straight line. There's no curve in the absolute value function. And so if you were asked to actually graph this on an exam, this is what you would have to do, and this is what it would look like. But again, in Hawks, all you're going to have to do is type this in right here. All right, now we're going to take a look at a second one. It's very similar, except you're going to notice one big difference as soon as I write it down. And so number 2 is going to be r of x equals, and we're going to have -3/2 the absolute value of x. And again, this is my function. And so before I do anything else, I should be able to look at this and very easily say, okay, well, again, my parent function is the absolute value of x. And in my mind, I know that it looks something like this. However, oops, that's a little off. However, in this particular case, since this is a negative number out front, I know actually that this is going to open down. And so instead of it looking like this, now I know it's going to look something like this. The vertex is going to be at 0, 0, and it's going to be opening downward. Well, in order for me to find those second points, again, I'm going to make an XY chart, and I'm going to pick -1, 0, and 1. I already know that this is the vertex because, again, I've asked you to memorize that. And so we know that the vertex is 0, 0, so we don't have to show any work for that. But I want to find f of -1 and then f of +1 so that I have some points that are close to my vertex. And so when I do this, I'm going to have -3/2 times the absolute value of -1, which is going to give me -3/2 times 1, which is -3/2. And so I'm going to have the point -1, -3/2. Okay, now I want to find the absolute value, or f of 1, so to speak. And so what's going to happen is the same exact thing. I'm going to have -3/2 times the absolute value of +1, which I know that the absolute value of +1 is just 1. And so I know that -3/2 times 1 is still just -3/2. And so the other point that I'm going to get is 1 -3/2. And again, if we were in HAWX, this is what you're going to have to be typing in. And what's going to happen is your graph is going to pre-populate, and your graph is going to look very much like this. Okay, it's not going to be exact, but it's going to look something just like that. And so somewhere over here is going to be -1, -3/2, and somewhere over here is going to be +1, -3/2. And so the point of these two particular problems is for you to get in your head when you're given a function, regardless of what it looks like. We have two that we've been given. We need to make sure that in our mind we can visualize what this thing is going to look like without having to put a ton of work into it. That's the whole idea behind the parent functions. Okay, so number 3. All right, so in the notes, we also talked about what we call a piecewise function. And so we're going to learn how to actually graph those by hand instead of just relying on the computer. And so here's the question. We want to graph, and then we have t of x equals, and then in this particular piecewise function, I'm going to have two functions, -7x minus 14 if x is less than or equal to -2, and it's going to be 1/2 x squared if x is greater than -2. And so what we're going to have to do here is we're going to have to realize that we have obviously two different functions. This is the first little guy, and this is the second little guy. And so what has to happen is, again, in our minds, before we do anything, we have to be able to say to ourselves, okay, equation number 1, function number 1, this is just a linear function. This is just x to the first, which tells me it's a straight line. I need to realize in my head, because my slope is negative, so I'm going to come over here, I'm going to say the first equation. It's going to be a line, and on my graph that I'm picturing in my head, I don't know exactly where, but I know it's going to be a line with a negative slope. And so I know it's going to be a line coming down. The second one, little bitty number 2 over here, since this is x squared, in my mind, I know it's going to be a parabola, okay? Because all all x squares are some type of a parabola. Since this is a positive 1/2, in my mind, I should be able to know that my parabola is going to start at 0, 0, which is its vertex, and it's going to open up like this somehow. Now, I also have to pay attention to the fact that each of these little guys have their own domain. Okay, and so when I look over here, this says if x is less than or equal to -2. So it might be helpful for us to write this in interval notation so we can see it. So if x is less than or equal to -2, what that means is that's from -∞ to -2. The other one says if x is greater than -2. And so I'm going to start at -2 and I'm going to jut off towards positive infinity. And so these are my two unique domains. And so what's going to have to happen is I am going to have to draw a graph, which I will do on this graph paper when the time comes. And what I'm going to do is I'm going to draw a graph, and there's going to be two functions graphed on this graph at the same exact time. And based on their shape and based on their domain, that's how I'm going to know what's what. And so the first thing that I want to do is I want to find some points for each of these. So I'm going to draw a quick XY chart for both of these. And so according to my domain for this first guy, it says I'm going to choose this function to graph if x is less than or equal to -2. So let's start with -2. And then let's put a few numbers that are less than or equal to -2. So how about -3 and -4? That'll be enough. And so what I'm going to do is I'm going to take these three numbers and I'm going to pop them into this x value, and I'm going to evaluate for -2, -3, and -4. Doing that will give me y values that I will turn into points and that I will put on my graph. And so when I do that, if I am trying to find, I guess in this case, t of -2, well, that's going to be -7 times -2 minus 14. And so -7 times -2 is +14, and 14 minus 14 is 0. And so I'm going to have the point -2, 0. And I'll graph these in a few minutes. All right, next, I need to find t of -3. So I'm going to do the same thing, except for in this case, I'm putting a -3 in for x. And so I'm going to distribute, and I'm going to get a +21. And when I subtract 14 from that, I'm going to get 7. And so the point is going to be -3, 7. And then lastly, for this guy, I need to find t of -4. And so I'm going to put -4 in for x, and I'm going to distribute, and then I'll give me +28. And when I minus 14, that is equal to a 14. And so now I have 3 points that I will graph in just a few minutes. Now, I need to go back and I need to do the same type of thing for my second function. And so I'm going to make a quick x and y chart, just like I did. And I'm going to say, okay, well, I know that my domain for the second function is if x is greater than -2. Well, I need to check the point at -2 as well, because since an equation exists at -2, there's going to be 2 pieces there. So I got to make sure that I account for that. And so I'm going to list some numbers that are greater than -2. So maybe -1, 0, and then 1. And that'll be enough. And so what I have to do next is I have to say, okay, well, I need to find t of -2. And so I'm going to go back up here to my second equation, or my second function, and I'm going to have 1/2 times -2 squared. Now, we're going to be able to type this into the calculator, and in fact, I encourage you to do so. And so what I'm going to do is I'm going to show you how, just in case you've forgotten, because it's been a while maybe. So you're going to have parenthesis, 1 divided by 2, close parenthesis, and then we're going to multiply it by -2, but we have to square that. So here's what it should look like when you type it in. Okay, and then I get a nice neat number 2. And so this is equal to the number 2, and so the point I'm going to have is -2, 2. Well, I need to go back and I need to do this for -1, for 0, and for 1. There's a trick on the calculator. If you hit your second button, and then if you hit enter, the thing that you just typed in will come back to you. You can scroll over and you can do a -1 instead. This is going to help you eliminate some mistakes. And again, some of you are going to have to turn this, I hit the wrong button. You're going to have to turn this into a fraction rather than a decimal. And so I'm going to have t of -1 is going to equal 1/2 times -1 squared, which is going to give me +1/2. And so I'm going to have the point -1, 1/2. And then I'm going to do 0, but guess what? I don't have to do a lot of work because I already know that this is my vertex. So I already know it's 0, 0, so I'm good there. But if you feel like typing it in, then it's going to be the exact same thing. And if you were to type all of this in, of course, we can bring it up and we can, cheat a little bit here and type in just a 0. And of course, I get 0, which is what I expected. And then lastly, I want to find t of +1. So it's going to be 1/2 times 1 squared. And again, I'm going to go back to my calculator and I'm going to type this in so I don't mess up. And when I do that, the number that I'm going to get, well, it's not 50. See, sometimes I even mess up on my calculator. 0, 1, not 1, 0, 0, 1. There we go. It's going to be 0.5 again, which we know is 1/2. And so I'm going to have the point 1, 1/2. Whew, okay, so now what has to happen is I have all of these points that I'm going to have to graph. And so I will grab my graph. And I will come over here and I'll do this color-coded so that you can see what's what. And the first thing I'm going to do is say, okay, well, the domains that I have, you can tell that they split apart at -2. And so what I want to do is I want to go to where x equals -2. And so I'm going to start at my origin and I'm going to go left 2. I'm going to say, okay, right here, I'm drawing a purple dotted line. Right here is where the functions are going to change. So I'm going to graph -7x minus 14 first. And I'm going to graph it in green. And it's going to be on the side of the line where x is less than or equal to -2. And so that is going to be on the left-hand side. And so I'm going to graph these 3 points first. And notice up here in my domain, since this is what we call the double inequality symbol, And since we have a bracket right here, we know that when we plot this point, it has to be a closed circle. So here I go. I'm going to start at the negative, or excuse me, I'm going to start the origin, and I'm going to scooch over to graph this first point, which is negative 2, 0. And it's right here, and it's a closed circle. And then I'm going to plot the point negative 3, 7. So over 3 and then up 7. 1, 2, 3, 4, 5, 6, 7. Okay, so about right here. And so what's going to happen is I run out of space. I can't graph negative 4, 14. And so 2 points are enough. And so I'm going to draw a line that starts at the point negative 2, 0, shoots up, goes through the point negative 3, 7, and continues. So I need to draw a little arrow. Now, technically, this is a line. It just so happens to stop right here. So I'm done with my green function. So I'm going to come over here to my orange function, which is the 1/2 x squared. I already know it should look like a parabola. However, it's only going to be occurring on the right-hand side of this purple line. And so I'm going to come over here and I'm going to graph these 4 points, but I have to pay close attention. Notice up here in my domain that my negative 2 is with a parenthesis. So that means when I go to graph it, it's going to be an open circle. So here I go. I'm going to graph the point negative 2, 2. And so I'm going to go over to the left 2, and I'm going to come up 2. And here's where I'm going to draw my open circle. If I were to make that a closed circle, this would no longer be a function. And so there's my open circle. And so then I graph the point negative 1, 1/2. So back to the origin, over 1 and up about 1/2. And then, of course, I have my vertex 0, 0. And then I have the point 1, 1/2. And so I'm going left, and then I'm going up 1/2. Now, these 4 little orange dots, they don't look like much of anything. But I already told myself, since this is a parabola, it's going to have to look like this. Well, on the left-hand side, this open circle, that's where it starts. And so I'm going to start over here at this left-hand side, my open circle, and I'm going to make the curve. And I'm going to continue. And so what's going to happen is my piecewise function is going to look like this. Now, when you're doing this type of a problem in HAWX, there's 3 steps. The first step is going to ask you, hey, take a look at this first function. Give me a rough idea of what it looks like. You're going to look for a graph that looks similar to this, and you're going to click on it. And then it's going to say, okay, hey, look at your second function. And it's going to say, give me a rough idea of what that graph should look like. And you're going to look for a graph that's in the shape of a parabola, which opens upward. And then the third and final step is going to say, okay, now that you know what they each should look like, based on the domain that I've given you, tell me what the final thing looks like. And so when it's all said and done in HAWX, you're going to be looking for a graph that looks like this. You're going to have 4 options. You're going to want to pay close attention to whether you have a closed or an open circle, because that's going to make or break you, so to speak. And so once you're in HAWX, you'll see what I mean, but this is going to be my total and complete answer. I'm totally done with this question. All right, now, number 4. This is still a piecewise function, but we are going to be evaluating it differently without a graph. Okay, so watch. So what's going to happen is we are going to have, again, 2 different functions. So the first one is negative x squared minus x plus 2. And we're going to use that one if x is less than negative 6. And the second function that we're given is negative 3x minus 3. And we are going to use this one if x is greater than or equal to 7. And so I mentioned earlier that we're not going to graph this. And so what's going to happen is we're going to have an A, a B, and a C part of this question. And part A is going to ask you to find f of 7. And part B is going to ask you to find f of negative 7. And then lastly, part C is going to ask you to find f of negative 4. Now, what's going to happen here, instead of me having to graph it, I don't want to have to do that. I'm going to just evaluate this algebraically. And so I'm going to look at my x values, and I'm going to come over here and I'm going to look at each of these little domains. And I'm going to say, okay, well, if f were to be 7, which one of these functions would make that, or which one of these domains would that fit in? So if I have f of 7, that means my x value is 7. So I have to ask myself, is 7 less than negative 6? No. And so then I have to ask myself, okay, is 7 greater than or equal to 7? Yeah. And so what I like to do is I like to say, okay, well, the first one is definitely going to be this second function. So I put a little bitty 7 that lets me know that when I get to this problem, I'm going to be using this equation. Well, then I'm going to jump down here and say, okay, what if I had f of negative 7? So I ask myself, is negative 7 less than negative 6? The answer is yes. And so when I go to evaluate f of negative 7, I'm going to use the first function. And then I say, okay, f of negative 4. This is my last one. And I'm going to say, well, is negative 4 less than negative 6? And the answer is no. And then I say, okay, well, is -4 greater than or equal to 7? The answer is also no. And so what's going to happen with this guy, he's not even on the map, so to speak. And so on this particular one, I can get away without doing a lot of work, and I can simply write undefined. And I'm done with that one because -4 is not in my domain. But now I have to go back and finish these two. And so since x is going to be my 7, I'm going to plug this 7 into this x. So I'm going to have -3 times 7 minus 3. And then, of course, I'm going to distribute. And I'm going to get -21 minus 3. And that's going to equal -24. This answer that I have circled, that's what you're going to want to type into HOX. All right, on this next one, we're going to do the same thing. However, we already decided that -7, we were going to plug it into the first function. And so I'm going to write the negative sign, a parenthesis, the -7 is going inside those parentheses. I'm going to square it, another subtraction sign, another parenthesis, my -7 goes inside my parenthesis, and then a +2. And so we have to be really careful here, okay? Because what's going to happen is the first thing we need to do is actually square -7. So verbally, when I square -7, I get 49. This subtraction symbol out front, this now means the opposite. So if this gives me a positive 49, the opposite of a positive 49 is a -49. So it's going to look like this. The opposite of 49. Okay, fine. If I have two negatives, that becomes a positive, right? Negative times a negative is a positive. So this is going to be +7, and then my +2 is still there. And so really, this turns into -49 +7 +2. And when I actually add all that up, I'm going to get -40. And again, this is what I have to circle, and this is what I'm circling. This is what I'm going to type into HOX. When you get to letter C and the actual answer is undefined, you're not going to type that in. There's going to be a teeny tiny little button. And beside it, it's going to say the word undefined. You're going to just click on that button. And that's it. That's number 4. All right, the last problem for this section, number 5. It's very similar to what we've just done, except for in this case, I'm going to have 3 different functions and 3 different domains. So my first function is -3/4 x plus 3 if x is less than or equal to -5. The second function is -x² plus 2x if, now this is that weird one that we had a hard time reading, so let me write it down and then I will read it to you. So this is going to say if x is greater than -5 or x is less than or equal to 1. So we're looking for numbers between these two. And then the last function is 2/3 x plus 2, and this is going to say if x is greater than 1. So now I have 3 functions, okay? So we can't let that scare us. It doesn't matter. It just means I have 3 different options. And again, I'm not graphing. I'm just going to be evaluating. And so I will have 3 pieces to this problem as well. And the first one is going to say find f of -2. And the second one is going to say find f of -5. And then the third one is going to say find f of 4. And so the first thing that I like to do is I like to look at each value that I'm trying to evaluate for and say to myself, okay, well, if x is -2, which one of these functions based on the domain am I going to pop it into? And so I say, all right, well, is -2 less than or equal to -5? The answer is no. And then I say, okay, well, is -2 greater than -5 and also less than 1? Yeah. And so when I come back to do this one, it's going to be popped into this second equation. And then I come down here and I say, okay, well, -5. And I go through that again. I say, is -5 less than or equal to -5? Yeah, it is. And so I'm going to put a little -5 here. And so when I go to actually evaluate that, I'm going to put it into the first equation. And then lastly, I have to check on the 4. And so I ask myself, is 4 less than or equal to -5? No. Is the number 4 greater than -5, but also less than 1? No. Is the number 4 greater than 1? Yeah. And so I'm going to put my 4 in that last equation. And so now I'm ready to come back up and start and actually do the evaluating. And so here I go. And so we had said that -2 is going into the second equation. And so I'm going to put a opposite symbol, a parenthesis, a -2, my squared sign, and then +2 times -2. And so we had this situation earlier. The first thing we're going to do is take -2 and square it, which in this case is going to give me a 4. This little symbol out front is no longer read as negative or subtract, but it reads the opposite. And then right here, 2 times -2 is -2. And so when I do this, I'm going to have the opposite of +4, which is going to give me a -4. And I'm going to subtract Wait, hold on, I gotta back up. I misspoke. I'm not adding here. I don't know what I was thinking. I'm multiplying. So this is going to give me a -4, not a 2. And so when I have this is a -4, and when I subtract another 4 from it, my answer is going to be a -8. And so -8 in Hawks would be the answer that I type. Okay, so now I'm trying to find f of -5, and I already decided that I was going to put it into this first equation. So it's going to go right here. And so I'm going to have -3/4, parenthesis, which means I'm multiplying by -5 plus 3. Now, again, my advice to you is to probably use your calculator here to eliminate mistakes. And so what you're going to do is type it in like this. You're going to have parenthesis, -3 divided by 4, close parenthesis, and then you're going to have another set of parentheses with a -5 on the inside. And that's going to imply the multiplication. And then out from that, I'm going to put plus 3. And I'm going to get 6.75, which is fine, but I want it as a fraction. And so some of you have an FD button. I have an answer to fraction button. Either way, you're going to get 27/4. And so without having to do a lot of work, 27/4. That's what you're going to type into Hawks. Done. And the last one for this section, the last piece, is to find f of 4. And so earlier when we went through and we found our domains, we said that if x was 4, we were going to plug it into this last function. And so let's do that. So we're going to have 2/3, parentheses, the 4 is going to go beside of it, which means multiplication, and then I'm going to add 2. And so again, I'm going to come over here to my calculator, and I'm going to do parenthesis, 2 divided by 3, close parenthesis, a second set of parentheses, which is going to contain my 4, and then I'm going to add 2. And again, I'm going to get some kind of decimal, whatever. I want you to turn it into a fraction. And so my final answer is going to be 14/3. And I'm going to circle that. And again, that's what I'm going to type into Hawks. And so now we have gone over all the questions that you can expect to see in Hawks. And so after watching this video, you should be able to go back and do those.